So, hey everyone, welcome back to our podcast. It's your host Shivam, and today's episode is going to be an exciting deep dive into the world of generative AI, prompt engineering, and LLMs. We have got a fantastic guest today with us. Meet Arnav Gupta from Synaptic. Arnav have been posting a great insightful content on LinkedIn, and I personally love few of them. So I can't wait for all of you to hear the from the man himself. So let's get started. Yeah, Arnav. So we would like to know how did you get into AI? Like,
Hi Shivam. To begin with, I really like the concept of you recording these calls and making this into a podcast. Like really good logs that you're keeping, and really helpful for people who are actually getting into the field of AI or data science together. So, like,
thanks.
yeah. Hi guys. I'm Arnav. So, I work for this firm called Synaptic as a senior machine learning engineer. And what Synaptic does, I'll just brief you through what my company around So, I've been here since 2020, and I was kind of interested around the space of startups as well. So I used a startup, and I used to do a lot of things around NLP, knowledge graph, and AI around that time. So I was just going through this Medium article once, and I saw this one blog. So that helped me connect to I pointed out the blog was around uh, knowledge graphs and how a certain company was actually using it to fetch better startups out there for the investors. So this really was a big thing for me because it opened a space where both of my interests aligned. So I reached out to the HR, I applied for the job, and this was right after college. I already had a job in place, but I thought this was much cooler. I had a job at a MNC, but I thought it would be much better to go into a startup as early stage. Like back then, Synaptic was small as well. Synaptic had almost 40 to 50 employees, I guess, and now it's almost threefolded. It's 150. So it's been 3 big years. So, what Synaptic does is Synaptic is a platform for the PE and VC firms to get information about companies on how well they are doing. So they focus on private equity market especially, and when I say private equity markets, majorly different from your public market where retail investors like us can invest in. But in private markets, more like the VCs, the PE firms, they put in money into these startups. Like you have heard of Series A, B, C round, right? So that space is totally taken over by VCs and PEs, and they invest in these startups with a huge lump sum of money. You must have heard $1 million, $100 million, sometimes more than billion, something like that. So what we do, our clients are these VCs, and our whole system is connecting the dots of different metrics. So for you, if you are into private market, the information about startups is really hard to get. It's not like public market where you are putting out filings and information about the companies, because the you are liable to the public retail investors. But in private market, you are not really liable to anyone, so you don't really have to put out your financial statements. So it's really hard to figure out how well a startup is doing just by the name itself. So there are certain proxies that we use to figure out. So you can think it as a data points that we use to figure out how give us each startup a score. So these data points are, first thing is as simple as employee count. If employee count of a company is increasing, you can say the startup might be doing well. Or if there is the number of visits for an employee is increasing, you can say the startup might be doing well. So there are certain metrics. Using those metrics, we club it all together for the startup to form an opinion, for algorithm start an opinion on how uh, what score to give, and using that score we generate a exhaustive set of startups that might be doing well, startups which might be in the downfall currently. So what we are doing is we are getting raw information in the form of time series or in the form of textual data through news. So in news as well, you can see if a certain segment or if a certain startup got funding. So using that information, stitching it all together, to form to build in insights for these VCs. So this is where like the whole Synaptics ML system come into place, and this is like what we had been handling since since 2019, 2018 we started it, and post that like till now we have grown a lot in those terms. So yeah, like uh that is what I'm currently working on. Sure.
That's really great actually. That's quite pretty interesting use case of an AI. Like this is the first time I'm like listening that we are defining different kind of KPIs using artificial intelligence to score the competitiveness of an startup. That's really a great thing. I'm sure you want to be really excited to work on that kind of a project.
Yeah, I mean it's pretty interesting, like each and every day you get to know about something. And like since we have recently sourced something like LinkedIn information, which is like the people data.
Yeah.
So I'll brief you about that as well, like how good or like what algorithms or what kind of systems that we are building currently helps get like all of the entities across the world in business space. Could be like startups, could be schools, could be investors, could be people. So everything is interconnected to each other, and how each and everything is giving each other a score through some algorithm. So currently we have just ingested this people data from LinkedIn like core signal, and we just are building a big graph of this. This whole graph is contained of these data points that I just told you, and using the interconnectivity and initial scoring, we can figure out like what all scores every person gets. So something like you can figure out Elon Musk must be having a much better score than someone who's a smaller founder. Some someone like Sachin Bansal, which is like might be getting a less score than Elon Musk. Sachin Bansal se come, there might be like very early stage founders of like companies. So we can given that scores, take schools into account, like which schools are good, which schools are not good, and like the whole network. The so VC is a big network game as well when it comes to data. Like you have company data that you have. So second thing is like the network thing, and now that we have started giving this network thing much more weightage over like the raw data that we used to give. So yeah, that's another aspect Synaptic is currently working on, and there has been like our hands-on news as well, like taking information from news, the raw textual format data, and this is where like most of the LLM use case also arrive. So yeah.
That's great actually. So yeah, Arnav, would you like to like tell us any AI and LLM project that personally like you are currently involved in?
So so like we had a lot. So since the advent of GPT, like a lot of things got easier for us, like in terms of NLPs. The space, that's something that we used to do. We back in my earlier, so before this Synaptic, I was in this firm called Abamo, which was like a startup around consumers, like not consumer service, but like customer service. We provided a chatbot, and we provided like interface for the end user to query anything about FAQs or documentation of a website. And what we did back then was like we created a knowledge graph of entities, uh, writing heuristics, right, taking some large transformers to fit in and do standardization as well. So back then we were building this knowledge graph of entities, and it used to be such a tedious task. Nowadays, when since the advent of GPTs, it's much easier. Like you put in a text and ask it to just give you the tuples back, like the subject object predicate, and use that as your graph entities and edges. It's much easier to build a knowledge graph nowadays out of news articles. So you can see like
Yes.
Obama might be connected to uh, Hillary Clinton somehow. You can see Obama might be connected to Africa, something like that. So it's a huge knowledge graph that you can build, and knowledge graph I think is the foundation of most of the question answering system at least back in 2022. Since the advent of like GPTs, what what has been a big thing for us was we started off building, like as soon as GPT came out, we started off building this internal thing called Synaptic GPT, where you can come in and like just put in information about, I want a startup in USA which was founded in 2022 by ex Google employees, something like that, and maybe you get information about it. A startup in AI space around copywriting, so you might get a lot list of startups which are doing that only. So building a GPT around that is kind of what we planned on and still are like thriving around. Initially we built a MVP, it worked out well. We had a lot of challenges around it because we were doing all of the RAG implementation and all together. So one of the biggest features that we shipped 2 months ago was the semantic search thing, where you can come in and search any kind of startup you want. Like,
Mm,
so that's the thing in Google right now. If you want to search, like what you do, you go search startups in video editing space using AI. You won't really get an exhaustive list and compare their metrics around it. So we just gave in a description search, which is more of semantic. So here it is a very big challenge because since we are getting a lot of information about startups, solely basing everything around just a single description isn't enough. So we had to use the website data. We had to use different sources of description, which in itself is a big prompt, you can say, if you have to summarize it all together for the
mm,
model to even generate an embedding out of it.
mm,
So like the context length used to cross. So earlier GPT's context length was like 4,000 or something. So we had to somewhat crunch all of it within 4,000 token. And one of the biggest challenge was like summarization. How do you go about it?
mm,
Biggest challenge that we face. So we went around building a lot of custom summarizers and even using the normal open source models and tuning it such that we can get the right keywords. At least for each company is given a big paragraph, we can get like 20-30 words of keywords around it, and using that as both as, so our search used to be hybrid. It's more of, so I'll tell you the components around it. The components more is, first you give it a prompt for search. Okay, so the prompt goes into this vector space. So like you embed it, you put it into vector space, and you have a lot of companies data, which once summarized, you change into a vector, you change again, like you do your cosine similarity against, which is very basic semantic search RAG implementation you can think of. But since it's not a RAG like generative answer, we didn't really want to get. We just want to get the cosine similarity of it. We got the cosine similarity, ranked it, but post that, like this is like every startup out there is doing currently. And for us to be somewhere even better, the results were coming out to be okay-ish, not that great when you do cosine similarity on that big of a set. So we are currently handling around 5 million, sorry, 0.5 million companies over which we have to do the semantic search in like less than uh, sufficient time. I mean, less than 10 seconds or 5 seconds to give out the best results that we can think of out there in industry. Because a lot of our competitors are doing the same, but what they're doing is they are just doing this normal cosine similarity semantic search. So we had to add a component of much better accuracy. So we used this co-ranker thing, re-ranker thing of Cohere.
mm,
So what re-ranker does is like it takes in, it has the Cohere re-ranker is a big LLM model, which is a cross encoder in itself. From what we can think of, obviously they have not made this public, but like what we think, like we also tried building a custom re-ranker in-house itself. What we used was like some cross encoders at the end, and the cross encoders used to re-rank the um, passages. Like once you get the set of passages, if you do cross encoding around it, like comparing each other against each, which is a kind of a tedious process, a lot of compute, a lot of time goes into. So we had to cut down that. So what what we were doing, our first filtering mechanism was, first funnel was doing normal semantic search, take the top end results, send that into a re-ranker. The re-ranker re-ranks all of it. Once you get the re-ranking, you you basically show it to the user. So there are like two levels of re-ranking and retrieval. So even after that, we were getting pretty good results, like, but that had a limit because the re-ranker cost was a big issue for us, the API that we were using. Second thing was, we couldn't get the entire corpus, as in like the re-ranker only used to re-rank top n, top 100, top a maximum it can support 5,000 um, items to compare against. So 5,000 rank you can only re-rank. You cannot re-rank entirely across all the companies. So we wanted a tool that can do that, and I think that need for us um, made us like get into vector databases. So when I say about vector databases, it's not like your Pinecone and all, which does that. Pinecone does something like internally, so they don't really disclose their algorithm as such, how they do it. We wanted to build something which is totally in-house, our own custom search. So we moved into ClickHouse, which can support a huge amount of data. And ClickHouse is a columnar database which provide a very good OLAP facility. So what ClickHouse does is, ClickHouse provides you is a normal database of like SQL relational database. Over that, you can add a vector side of it as well. So one of the data types is vector, and it supports a very fast vector retrieval as well. So we thought of moving all of our algorithm, once we get the embeddings as such, all of the re-rank and everything, to move into re-ranking and even doing semantic search just using SQL. So all of this is happening inside your query itself. You're not taking out the vector in Python or something, because first we wanted a fast system. Putting Python in place was actually kind of a hindrance for us. We knew what mathematical operations needs to be performed, and we wrote it down through a query, did the normal cosine search, and then post that we do a re-ranking just inside the query itself, which was the cross join thing which the ClickHouse provides. ClickHouse is pretty cool library. If not, like, it's not sponsored obviously, but like ClickHouse is one of the very good databases out there currently. Apache Doris is coming along, but it doesn't provide the vector facility yet. But in terms of doing most of the machine learning tasks, if it's more of a mathematical thing, if you have to just do cosine similarity, in terms of search at least, ClickHouse is coming out to be pretty well with its cross join functionality and normal cosine similarity. So we actually came out with a pretty decent results, and in a like we were able to query very bulk of data, get back all of it, all of the data points in the order of their score, not just the top 5,000, all of it. So this like made us independent of Cohere. Second thing was everything was doing in-house, so like it reduced the cost and was a kind of upgrade over a search system. So this is what we shipped out recently. And
That's really great. Yeah.
yeah, so in that is like what we worked on. Now we are starting to work on, so that was a generative part of things. Alongside that, like, we are actually every day I'm getting into hacker news, reading around GPTs, and trying to see like how we can build in a custom GPT, so that we don't really have to rely on OpenAI or anything else. So all of these that llama models are coming out, how can we optimize it to run it on our smaller machines instead of larger machines, to fine tune it in a very fast fashion to get the best results which are comparable with GPT-4. So we
Hmm.
are working on that as well. So I think, if you guys don't really know, recently there was this PEFT thing that came out. If you know of like parameter efficient fine tuning,
Yeah,
the
yeah.
yeah. So what it does is like it kind of minimizes your computation and your resource footprints altogether. So it allows you to like train your AI models in a very broad range of hardwares. Like I remember seeing this particular article. Someone trained their AI model inside a Pixel phone. So
That,
using Deft only, yeah, parameter efficient fine tuning. So and that is like something pretty cool. And we are also like checking out and understanding how we can go about it. There were so like something I think few days back only Llama adapter came, if you remember. So what it does is like you can get very good results from Llama, and just by compressing the model and be at par with something like GPT 3.5 just
mm,
using Llama 2.
mm,
So there are multiple methods that they pointed out. Like so, when Llama adapter came, it kind of took into two of the previous mentioned methods. I remember one was around i- prefix tuning, and one other thing was around just the normal adapters that came out for transformers. So if you want me to get a bit technical, I can get into that as well, around like what all different adapters that came out and how they helped around with the tuning and making the model to work on very small devices. So I've been reading around it a lot, and maybe I was thinking of writing a blog around it as well. So I can just give you a gesture of it, like what prompt prefix tuning was and what adapters were. So the prefix tuning is more of a like uh, hack around your transformer. What we do is like instead of give, so there are something called soft prompt tuning. Something
mm,
called hard prompt tuning is like you yourself giving a prompt and just changing and checking out results and again.
mm,
So that's like most of the people do, which is like hard prompt tuning. For
mm,
soft prompt tuning is it's just to add a trainable tensor to each transformers block instead of only the input embeddings.
mm,
So like usually what you do is like you put a trainable tensor just on the input tensor, but like you can do it for the each block as such. So using that, like it it can achieve up to model performance of like same as if you, so there are multiple ways of fine tuning to start with. One of the fine tuning is you just have a top layer. So you have a LLM, you get the embeddings, you have a top layer, you just add single layer, you add it for the classification purpose. Okay. Second thing of prompt tuning is sorry, fine tuning is you actually adding a full dense vector, sorry, dense network at the end of your uh, LLM models, like embedding that you're getting. So training that level vector, dense network.
mm.
So it doesn't train the LLM, it just trains the dense network. So third third time of fine tuning is like you actually training all of it, like the LLM side as well. So if you train the LLM, it is more costly. It turns out to give a much better results in terms of like you just uh, train your the top layer. So it's better like if you train all of your, so there are like three types of fine tuning. Usually when people talk about fine tuning, it's mostly around just the last layer because it's much more it is kind of efficient and less costly. So there are like, this is where like prompt tuning and prefix tuning comes in. What it does is it it just says ki you just add a few layers inside your LLM, and you just make those trainable. So these four layers, like if you add it right after your full dense network inside your LLM, instead of training all of your network, so you can disable, enable whatever layer you want to train. So in your big LLM, if you just like put in four or five these trainable tensors and you just train them, and the last layer you might get a decent enough accuracy which is at par of fine tuning the entire model, like an entire LLM model. So this was kind of cool because like in terms of fine tuning, a lot of people do face this challenge that they don't really good get that good of a result, and the LLM doesn't really get in. The embedding that you're getting won't really contain information specific to your domain. So, I mean, that is pretty cool in terms like how you can fit in, how you can do very good fine tuning, get better results, and fit in a small model, and maybe use that instead of using your entirely big, which could adhere to a lot of cost for companies currently. Yeah,
Definitely. Actually, yeah, there has been lots of debate is going on using universal LLMs versus tiny language models. As you have correctly mentioned, like we can build our own custom tiny LLMs models, just training the like the upper layers that you can achieve better results in comparison to universal LLM for a specific task.
yeah,
And
yeah.
that
So,
is that
but,
completely makes sense. So yeah, you were saying something.
yeah, so that's like kind of intriguing because nowadays it's like more of, I think, even people want to, I mean, at least the big companies don't want to rely on OpenAI solely for these purposes because generative AI is big currently, and uh, people would want to build something of their, like something they can host on prem, uh, as solely like not using some external APIs for it, because like it kind of adds a dependency, and in terms like the OpenAI service or some other service goes down, it like could hamper you guys as well. So yeah, that's there. And plus the another reason for us to build the in-house LLM model is the data privacy thing as well, because all of these investors are putting like millions of dollars currently in startups,
Hmm.
and the information around it is pretty sensitive. You cannot you cannot compromise on some other investor getting some other investor's data, which is a very bad example in the space that we are currently working on, because it works with networking, and it works with what other investors are talking about. If other investors get to know even a slight a bit, they can get into a deal and may hamper a deal of like 10 million, 30 million, something like that. So all of this information is pretty sensitive. Sending it out to OpenAI is kind of hard for us. So we don't really want to do that. And even if we had like we tried thinking of like actually sending it out till the time we create our own LLM, um, like host our own LLM. So one way is like you actually mask the information. So another trick is like you put a hash function, kind of a hash function, where you add one digit after every fourth consecutive letter, or like something like that. You create a rule which can encode and decode your data. So you encode your data, maybe replace numbers that you're getting for a certain startup, replace it with some multiplied by 10 to the power 3 or multiplied by e to the power 7. Send that number instead of exact number. So that is some jugaad that we can say, but I don't think so that's feasible. That's why like we even went ahead thinking of like deploying our deploying our own Llama 2 or some open source LLM.
No, that's really great actually. Sure. Like you talked a lot on prompt tuning and LLM fine tuning both. So in your experience, how do you balance between let's say prompt tuning or prompt engineering and LLM fine tuning?
So I mean, both are kind of uh, both kind of achieve the same task. So like for example, let's say I want to put in a news article and I want to just extract the metrics out of it, certain keyword metrics out of it. Fine, this is my task, and I give it to a GPT and I ask like extract me all the financial metrics uh, from this passage. So it will extract it, but sometimes it won't really follow my guidelines as such. Like I won't be getting the right set of either the set of results or right format of the results. So if I ask like give me back a JSON format, So it's not really giving me back a JSON format. I have to write it in some fashion, strictly give it back to me in JSON format, or add certain keywords. So I mean, so recent, like apparently recently only, when Pydantic came out with their solution around it. So Pydantic is a really cool framework. If any one of you guys haven't heard of it, I think you guys should try it out. So Pydantic, along with LangChain, came out with their basically, it's Pydantic is kind of a data class, only data class of Python. What they do is like they provide validation and a way of describing your data. Like your you have a class, something like um, a ship. A ship contains of a, like a sailor, um, a captain, a crew, and staff, something like that. So inside ship you have these. So you can describe these like captain is the captain of ship, something like this. So you can send this object through OpenAI's, not through OpenAI, but through LangChain, which converts it into a prompt. And that prompt template is basically giving you back the result in that class format itself. It parses, give you back the results in the class format itself. So you would be getting a pretty deterministic output always in those terms. So uh, I see a lot of people actually facing this issue of them actually writing in prompt, "Ki give it back to me in JSON,"
Mm,
and like they specify the type, like what the format of JSON is, and then doing some regex over it to figure out, okay, now it's fitting the regex. Just take it out like that, convert it into a JSON object, and once you are done with that, then you start processing. So Pydantic makes it so simpler. So like I really love the Pydantic library. So like I especially use it when I'm doing like hard prompting, just putting out the prompt and getting back the results in a defined format. But
mm,
for some cases, like the case I had told you, extracting the metrics. Now the thing is that these metrics for OpenAI, for GPT, it's like always a different like context for it. Like even if I provided an exhaustive list of metrics, it won't really be able to get the like it won't be really be able to get like what standard metrics are. So it could be like my metric list is so large that it doesn't fit into context length. Then what will I do? Then this is where like I have to go about you like fine tuning my model, fine
mm,
tuning it so that I can reduce my like the prompt as such. Like I don't really have to give the list again and again. It will
mm,
learn using the prompt, using the fine tuned examples that I'm giving. So I'm like giving it example of like, give me out the metrics for this news article, these are the metrics for this news article, these are the metrics. So it will
mm.
understand the pattern, and it will understand like I have to only get the metrics of which are like more of financial space, not normal metrics. So using that, we I like what we built around news was like we were able to figure out what all metrics we need to figure out, and putting that unstructured information into a structured formation. So yeah, that is how we use normal prompting and the fine tuning thing in our
That's quite insightful actually. Acha, so when you said ki okay, we do extensive fine tuning so that we can train the upper layer, the model rather than the hard prompting. So how do you even like every time, let's say you build the model and then you are shipping the like the product, then every time the user or some that every time the input will keep changing. So
yeah,
how
I
do
mean,
you make sure the
input
model
summary.
gets the right input?
So in my case, the input summary is usually different articles. They keep on changing. So few articles won't be having certain metrics. Few might be in the format of like very different format. It won't be You won't be able to pass it properly as well. Like there would be lines, there would be a lot of, I mean, you would require some kind of pre-processing over it, and post that only like whatever we think fits as a good paragraph, that only we put in. We don't really put in like some garbage table content text currently.
Definitely. So, like when you mentioned pre-processing. So, is that pre-processing can be handled by prompt engineering itself? Like you can transform the input itself, good prompt, then you
So,
pass it to your fine-tuned
so, so we are pretty uh, like we always try to keep our price into check. So we don't really want to give much of much of the context as such. Like that will increase our cost. We would want if we can provide a shorter context using some heuristic, using some other methods that we can think of. We tried doing some pre-processing from our end. Obviously, like from prompt engineering and yeah, if I could get a template around how to do the best pre-processing of at least news text, I would be maybe thinking of giving it a try and benchmarking it against our heuristics that we have. If that works out pretty decent, maybe
Mhm.
we would like to think of using the prompt in such a way that like it pre-processes as well.
Right, right. Acha, so one of the key challenges that we see like people are facing with is like whether they are fine tuning the models or whether they are like doing the prompt engineering. So how do you evaluate the generated output text from LLMs?
Yeah, so I think that is a tedious task. I mean that is a problem I think a lot of people are facing currently as well. Uh, Nowadays people don't really have a gold standard to compare it against. People are rather generating gold standards through LLM and comparing their own internal model against that. So
But
taking that,
again, like evaluating those gold standard is a challenge.
yeah,
It's
exactly.
like a chicken and problem.
Exactly. That's one of the biggest challenges. I think there are tools out there. Grok even put out their own. They haven't like put it out yet, but they put out in their blog the Grok, the XAI thing that Elon Musk started. So they have their own easy prompt engineering. So something like what you guys are building. I don't know you guys have seen it or not, but they are building a software for evaluating these prompt, like different prompts, creating a history around it, and versioning each prompt, seeing how well each is doing against another, benchmarking their results. So Grok is working around that particular tool. So I really found that interesting, and I see the reason as well, like why they thought of building this out. It's a very interesting thing to do, because like it's really hard to, unless and until you make someone sit and verify the gold standards of
Yeah.
GPT, then only it makes sense. It's a very tedious task, and I wish like there are better methods around it.
Maybe we will be discussing about that when I saw the limo. Okay, so do you think like measuring the performance of our LLM features in production like is important?
Yeah, obviously. I mean, so the thing is, people nowadays have this perception that if they build a MVP with GPT, it would work the same in production as well.
Mhm.
And like the expectations they have usually don't really match. LLMs are good enough for MVPs currently. The stage of LLMs at least is good enough for MVPs. To make it a production level, it requires a lot of challenges. It's not a straightforward process. You have to like, as easy as you have to work with mm, different prompts. You have to, like, once your prompt is out there, you have to evaluate your results. If you don't find the results good enough, you have to do some pre-processing again, maybe train your own fine-tuned model further. Then there are like multiple levels of fine-tuning that I discussed earlier, like just training the last layer, last network, or maybe putting different layers inside your LLMs, training that, and maybe training the whole network altogether. So I mean, yeah, that's how I think uh, like people usually go about putting these LLM models into production. Once it is out there, once it is in production, it's really, so the whole LLM thing is like it works as a black box currently. It,
Yes.
so to to get the right results out there, you have to get into the nitty-gritties of like fine tuning it, or maybe pre-training it at some cost. Like for big corporation, at least, like they're pre-training it over. So like I think that's the biggest challenge currently for us is um, to get into production. Once it is in production, it's good. Like if you can keep it in production and people are happy with it. But like this is how at least we in Synaptic go about putting our efforts when we are putting something out in production. And still we are yet to put out things that we have worked on generative AI, because we are still not confident like how will the results would be.
Definitely, definitely. So, moving to the end of our podcast, like, so how do you ensure you are up to date with this evolving generative AI landscape?
So I'll tell you about that. Like I've been following AI since forever, and I try to nuke myself with whatever article, whatever feed I can get. So I created a bot around it as well, which especially does that. So I scrape Hacker News, I scrape Reddit, I scrape Twitter, and I actually pay Twitter to scrape me all the AI happenings currently. Summarize that, use GPT around it, and summarize that and send me a morning Slack message what all happened yesterday. So this is how I go about
That's
it.
that's quite of a work to just be updated on the.
Yeah, but that was a cool project. I made a
Definitely, it's a cool one.
yeah.
It's a cool one and it's quite useful
It's actually
for
useful.
anyone. Yeah.
It's not just around AI. I've done it like across startup space and the like entrepreneurship space as well.
No, it's really good actually. It's quite great.
And I think like maybe in future I can actually add this as a feature in Synaptic.
Definitely, definitely. That would add value to the end users of the Synaptic for
Yeah.
sure. Okay, then, guys, that's all for today. We discussed quite in detail today the like the LLM fine tuning and prompt engineering, and so you would have find it quite insightful. If you have any questions for Arnav, then please put it into the comment. We'll reach out to the Arnav and we'll get the answers for you. So thanks, Arnav. Thanks a lot for your time today, for sharing your experience and the learnings with the community. It was really
Thanks,
great.
man.
Actually, we
Thanks
learned
from
quite
your
of
side.
new things. Yeah. Okay then. Thanks. Thanks a lot, Arnav.
Thank you. Bye bye.